Okay, so we're going to talk about stuff we did before exponents, and then we'll jump into some exponents as well. But I want you to remember, let's get into this part right here. I want you to remember, move this over, how to solve these ones. And if you've forgotten, there's some major things I want you to find out or look for when you're dealing with this problem. When you're dealing with this problem, I want you to remember that there must be a right angle you're finding. You're always looking for this right angle, okay? Now this right angle's right here. It's almost like a little mini square. Once you find this mini square, you can tell what your legs are. There's a leg here, and there's a leg here, and it's also written, it almost looks like a perfect L. You're looking for the L here, all right? And the formula, if you've forgotten, was leg squared plus leg squared equals hypo squared. So make sure you have that written down on the top of your paper. You can always use your notes when you're attacking different problems, okay? Leg squared plus leg squared equals hypo squared, okay? Now, what we're going to look at here is where are the legs, where's the hypo? If we're doing the first part, we can say this is 6 squared, 8 squared equals, and this one's actually called x, where the hypo is, x squared. The hypo is always going to be the longest side, too. So knowing that right now, you could tell me that your x will be greater than 6 for sure, and 8, because I just told you that the hypo is going to be the longest side. So you could think about it saying, okay, I know that the hypo has to be bigger than 8. So it could be 9, it could be 10, it could be 100. I know it cannot be like 4 or 5 or 2. It has to be bigger because the hypo is always the biggest, always the longest side. So for this one, you don't even need a calculator. We're just going to bring this down. This is 36, okay? 6 times 6, 8 times 8 is 64. And if you used a calculator, fine, no big deal. I have no problems with that. You're supposed to use your calculator as much as you need to. Then, let's go ahead and attack this. This is going to be 100. And if you use the calculator there, that's fine too. I want to make sure you're perfect. I want to make sure you're accurate. Accuracy is more important than just going quote and guessing or kind of sure about a problem. Now, what is the last step? I got to get rid of this guy here. I want my answer to be all alone with an x, okay? I don't want it to be with that little exponent. So what am I supposed to do? How do I kill the exponent? I stab it with a square root. All right, once I've stabbed it with a square root, it's gone, okay? And this is 10 equals x. All right? And there your final answer would happen. Now, with Pythagorean theorem, sometimes you're going to be given the leg and the leg, like this one was, but sometimes you'll be given a leg and a hypo, and you'll have to find the other leg. Okay, there's different types of Pythagorean problems. There's only 2 different types, really. Okay, let's go ahead and do another one here. Let me X out of this one, X out of this one, and go. All right, so this problem, we will use the calculator because this problem has some bigger numbers on it, right? So we want to deal with this, and we're going to go ahead and remember our formula. Leg squared, hypo squared, okay? And then from there, we want to think about, all right, what are we going to plug in? 7 squared. Now, why did I think that was a leg? There's my right angle. It tells me everything I need to know. This is a leg. This is a leg. Okay, that's super important. So that's how you found your leg. How did you find it again? You found the right angle. Don't forget the rule, what you're supposed to do. You need to find this right angle. I think of this little mini square to figure out where your legs are. Now, 7 squared, what's the other one? Well, this is a leg, so is this one. So this is 24 squared equals x squared. So this is just like the last problem. We just have bigger numbers. So let's go ahead and talk about that. Let me go ahead and open up my calculator, clear all, and excuse me, when I go ahead and attack this problem, I'm going to go 7, and then don't forget about this button over here, squared, okay? 7 squared plus, and what was it again? 24, okay, 24 24, and hit the button, square. And I get 625. Okay, that's good. We're halfway there. We're almost done. So now I got 625. So let's go and put that there. 6. I was trying to use my mouse. I don't use my stylus. 625 equals x squared. Okay, now we're almost there. What is my last step? We have to, you got it, kill the exponent. We got to square root both sides. So when we do that, we'll have our final answer. Okay? So we're going to put square root of 625. And we get 25. So that's our final answer. 25. Okay? 25 equals x. All right, now let's go ahead and try another, actually, different one. We're going to do one more triangle problem. One more. And this is a great one. I think you even had on your quiz at one point. So let me take a screenshot of it. Now, looking at this problem, my first thing I want you thinking is, can you find the right angle? Can you find your right angle? The little square. If that's not labeled, that's going to be difficult for you to find your L. Excuse me. So finding the L, you must find your right angle, and now, awesome. You know that this right angle is attached to legs. This leg here, all right, you found that leg here, and then this leg here. So those are your legs, and this is your hypo. We'll call it H if you want to. That's your hypo, okay? But honestly, we don't want to call it anything. We already know what it is. What's our hypo? 26. So we know what the hypo is, which is important. If I have to put the formula up again, I'm going to do it quickly like this. Leg squared, hypo squared. And then I'm going to start plugging in stuff because I know what some of this stuff is. I know I have one leg. Okay? I know I have a hypo. All right? So let's go ahead and plug in this problem. I'm going to put 18 squared because that's a leg. Plus, isn't this a leg too? Y squared equals, what's my hypo? The longest side. So let's go into detail again. This longest side is the hypo. So I know this y cannot be bigger. It can't be 27. The answer to this cannot be 27 because it cannot be bigger than 26. It has to be smaller. Okay, it can be bigger than 19. It just cannot be the longest side. And you're going to see triangles a lot. Let's say they're not drawn to scale. So don't just look at this saying, oh, I think this is longer than 18 and just assume it's going to be longer than 18. We're going to do the math on this though. Doesn't this require some math here? Can we use our calculator? Of course. Isn't it important though to first figure out this number here and this number right here? All right, let's go ahead and use our calculator. What do we get with 18 squared and I think, what was it, 26? I forget. 18 squared, 324. So go back to it. We're going to write 324 plus y squared, that can't change, equals, and let's go ahead and take a peek at our calculator, 26. So I'm going to go hit enter because I can't add those together. We're not supposed to do that. Pay attention. 26 squared is 676. So it's 676, okay? Now, we're not allowed to add those. I want to make that clear. If it was right here, we could add them together, right? Because this is an addition here, but that's not happening, all right? So what do we have to do to solve this problem to eventually get y all alone? What do we have to do? Don't we have to move something over? Shouldn't we get this out of here? Beat it. We got to get you out of here. Don't you have to subtract with these kinds of problems? So we're going to go ahead and do that with our calculator. 676, enter. I'm going to go 676 minus 324, and I get 352. Okay, great. That's great. We want to get something like that. I got 352 equals y squared. And I know my work's starting to get a little jumbled up down here. But remember, what's our last step? We got to kill the exponent. Get rid of it, kill it, annihilate it. Once you do that, you got to do the same thing to that side, and let's get our final answer. We're going to square root this answer we got, 352. I'm going to hit enter, square root, 352. And my final answer is 18.76. If it said round to the 10th, I would go ahead and say, okay, it's 18.8. This 6 right here would bump the 7 up to an 8 if it said round to the 10th. Okay, if it said round to the 100th, you would keep it like that because that 1 would not change the 6. But if it said round to the 10th place is a 7. This 6, 5 or more raise a score. This 6 would raise the score to 18.8. All right? So that would have been my final answer, 18.8. Okay, little Pythagorean review, which you guys need. We haven't gone over this at all the last 2-3 weeks, so we've got to go back to it. Make sure you don't forget these concepts. This is a very important concept. All right, now let's go back. Okay, so we're going to go back to this problem. This is a problem we would have to deal with yesterday or Wednesday. This is kind of a review again of what we've been doing with exponents, but multiple bases. So this one, a little interesting. We got to go through and deal with this part first, all right? And then deal with this part second. So when we're looking at this, remember, what's the A going to win? The A battle happens. Who's going to win the A battle? The 8 or the 3? There's no negatives in this problem, so you don't have to flip anything first. There's no negatives. This is kind of a nice problem when there's no negatives. The top is going to win by 5. Why did that happen? Because the 3 came up and subtracted 3 from the 8. All right? So now, let's go ahead and look at this other one, the B battle. Who wins this B battle? The top or the bottom? You can tell the bottom's going to win. But how much? You're going to take 2 away from that, you're going to get B squared. Okay? Now, let's kick it up a notch. We're going to keep going through. And this one has multiple bases again. I have 2 different bases. I have 5s and I have 6s. What's the rule here when you have the same base and you're multiplying? Right? Aren't you supposed to add? So these 2 bases here, I'm going to just circle this as one whole problem. That's one problem. All right, and then this is another one. So this one's actually fairly simple since there's no negatives to deal with. But we're not scared of negatives. So we know how to deal with negatives. We're not going to let negatives beat us. In the next problem, there will be some, so don't let them mess with you. This is going to be 5 to the 14th times 6 to the 14th. Okay? And sometimes I'll put them right next to each other without that multiplication dot. Right, did I mess that up? I did. Why would I say 14 when it's 8 plus 4? 6 to the 12th. There we go. All right. Now, let's kick it up even more. We're going to do one that has some negatives in it. Let's see how you guys do this one. For this one, let's go ahead and tackle this one. Same bases, all right? I kept it pretty simple. This one's not going to have too much craziness. Do this one. If you're adding 3 and -2, you're going to get 5 to the 1, but guess what? You don't have to put an invisible 1 there. It doesn't have to be there, all right? It's there, but it doesn't have to be. It's there, but it doesn't have to be, all right? And then what about the 6? -4 plus 5, again, 6. I would put a point there to make sure you know that there are separate bases. There could be 1s here, but they don't have to be, okay? Kind of a weird problem. All right, we're finishing up now. Let's pay attention. Don't get lost on me. This one looks a little goofy. We didn't spend a lot of time talking about this one. But if we're going to deal with this one, the idea is you want to get this simplified first. You want to do this part on the top first before you do anything else. Do that part first. And that part is pretty easy. You know that rule. You know what to do. We just did that rule. So we're going to go ahead and do that. We're going to get 4 to the 15th. Remember, you add them. And then I have 4 to the 6th. All right, what do we do here? Isn't there a battle happening? Wouldn't you just basically bring the 6 up and subtract it? All right? When you subtract that, you're going to get 4 to the 9th. The top wins by 9. These 6 knock out 6 of those 15. That's why there's only 9 left. All right? Very nice. We're almost done. Stay with me. I know that seems like a lot. You got this. All right. What about this one? Let's talk about it. We're going to go ahead and first tackle the problem. So this one's interesting because there's no A to deal with. There's an A on top, but there's no A on the bottom. And we really haven't talked about that much either. If there's nothing to deal with it, it's just part of your problem. All right? I mean, part of your answer. It's part of your answer. Okay? Now what about this B battle? Who's going to win that battle? The bottom by 2. Doesn't the 2 come down, subtract from the 4? Okay, cool. Now the C's. What's going to happen with these C's? First of all, what are you supposed to do with that? Go ahead and bring it down. You're going to add it, right? Isn't there C3 now in the bottom? Go ahead and add those down. You're going to get C to the 5th. There we go. It looks weird. You'd usually put your A like right in the middle. You know what I mean? So it would be A to the 3rd, holding this fraction together. Okay? This is definitely high school level. In 8th grade, these are all going to be integer bases. But in high school, they're going to be variable letter bases. All right? So I think we have like one more. Cool. Last problem. This one is a newbie. You haven't dealt with this yet. So that's why I love showing you something that you haven't seen yet. Because honestly, you could attack this problem without ever seeing it. And that's something that's very interesting that I think you guys don't really have confidence in yet, is looking at something that you've never seen before and kind of getting through it and knowing and discovering it. So when you look at this problem, I would hope that you would see the middle part first. Oops, I can do this here. This middle part first is important to look at. Now, if you had to solve that problem, go for it. Let's go inside the parenthesis and work our way out. Do you remember that rule PEM does? What was the P? What did the P stand for? Parenthesis. So you're supposed to deal with stuff in the parenthesis first. So if you were to deal with this part here, 2 to the negative 8, 2 to the 3, all right, remember this problem would look like this, 2 negative 8, 2, 3. I'm writing it again because it's kind of small there. I would add these, right? But negative 8 is going to be, negative 8 is going to win if I add this, and 3 is going to get taken away. So it's going to be 2 to the negative 5th. If you struggle with this math, aren't you using a calculator? Aren't you plugging that in? Even with your cell phone calculator, you could plug that in. You could plug in negative 8. Remember, I showed you that button that it has a plus and a minus on it. You could change it to negative 8 plus 3, and you'll get negative 2 to the negative 5th. So all of this is just changed to what? 2 to the negative 5th, right? And then what's still on the outside? 3. Hey guys, that's nothing new. What you're looking at right there is nothing new. You can all solve this. This is nothing new. Negative 5 and 3. All right, you're going to multiply these. You're going to get 2 to the negative 15th. All right. Wait a minute. I don't see my answer. Yeah, you do. You know what it turns into. And that would be your answer. You know that 15 has to drop down. Okay? So that was a lot to look at. You had to do this part first. If I had to erase everything on here, I don't think I can. Yeah, if I erased everything, again, you're looking at this problem. You're doing the middle part first. All right, then you're dealing with the 3 on the outside. All right, and then you finish the problem. All right, guys, best of luck. Have a great 3-day weekend. I will see you guys on Tuesday or Wednesday.